Yes.
All right, so let me just explain what we already have and what is our goal. So the goal is to basically do a Roth interpreter. So we are not gonna do with the if we have time, then we can do the types and all that. But we are gonna be starting with the Spoon compiler. So it is a compiler and interpreter. First, we are gonna do the interpreter because it's easier to validate stuff. And we already have a project set up, and we're gonna be doing Erlang. So if you guys can join, just join. Just join now, Lemus.
Yeah, I'm
That's
trying.
it. So this is the language we're gonna be doing. So it's basically a S expression language that we want to be strongly statically typed. So
And this is probably not the final syntax, by the way.
Yeah, for sure.
Yeah. Oh man,
Like,
no.
it's open to
This looks
debate.
good. Actually, I just noticed this is wrong, right? It should be like.
Yeah, it is wrong. Like, you should choose another syntax.
Yeah, but shush. Anyway, so just do this because it's giving me okay. So we already have highlighting and all of that. So it's basically Lisp inspired, but we don't want to steal too much from Lisp. We want to still keep the originality of ML, like pattern matching all the way. Anyway, so let's start. So last session, well, I don't know if we can count that as a session. We just did out of a desire. We made this thing. We don't know Erlang, so we just made what we thought was convenient at the time. But I think it's better if we split these functions into just expressions pattern matching the parameters instead of pattern matching with a case inside the thing. So let's first.
Oh, okay. You say regarding doing the pattern matching on the high level, right? On the declaration.
Yes, exactly. Yeah.
Yeah.
So let's start by that. Let me just disable this thing. I don't like this minimap.
By the way, we don't have like types, right? Like, we don't have stat typing, right, in Erlang?
I think you do. You can expand. It has macros and stuff, but I don't know how they work.
But I mean, like, as we usually have in ML, like the way that we have. Okay.
No, that case, I think it's
so
not even
we
close.
cannot declare like those structures that we are going to receive on those functions, right?
No.
So what about we at least doing a comment on how the structure looks like? Because otherwise,
yeah, we can do a spec.
Oh.
So which is like this, I think. I think on Emacs it shows. I don't know. Is somebody gonna join here?
I will. I'm trying to join. I discovered that I can't join via Linux because, well, Nix, probably Nix. So.
Okay, because I think on Emacs it shows like spec, for example. So I would go there. But anyway,
no,
like
if we get more productive on Emacs, like significantly more productive, we can go there.
We
can go to with Emacs.
Like we have this stuff here, like this, so we don't need what? Okay, it's because of the spec. But anyway, like that's fine. So we can add specs. We can look into that, and that also works for generating documentation at time. So you can actually add something related to types.
Yeah, but my point basically
not gonna be amazing, but
as we don't have a type to represent our AST, let's do something to at least picture the AST that we are designing and operating on.
Yeah.
If you can implement that.
Stop. Sorry, Magetta, you can go to Emacs. I don't think this is gonna roll, so feel free.
Why?
Man, the web version is still loading forever, and the Linux version doesn't work. I think it's not worth it. Just
web
go with
version.
The web version.
Yeah.
Right. I'm free. All right.
So Magetta, if we can implement that with spec, great. I would bet that we cannot do that right now because we would need to know how that
let's
works.
focus on breaking first.
Yeah, but that's the thing. Let's at least do comment on how the AST looks like.
Yeah, but just
otherwise it's too abstract, man.
Okay, so it's matching. Oopsie. All right, so let's just break down and then we can fix that. So this is a literal. So we get environment and the expression, but in this case we don't care about the environment, just the literal. And then we want to propagate that thing. So let me just, and then we can do this as I think no. As was it like this?
Wait, you
No,
are
sorry.
ignoring
Equals.
there?
Yeah, why
So,
I don't need, right? So I can just use expression here.
but do you get the default value for that then on the?
I can do, yeah, I can do like this.
I'm not
I
understanding
don't know.
this code. No.
No,
I
no,
can do like
no,
this.
wait, Nathan. Put
Okay.
into your mind that every single capital letter is not a type or nothing
Yeah,
like that.
it's
It
No,
is a
no, yeah,
variable.
a variable.
I know that, but I mean, why is he ignoring the environment?
Because
Well,
if you have a literal,
I don't need that.
the
Oh, okay,
return
okay,
doesn't
sorry, the
matter.
pattern matching. Oh,
Yeah. Think of all pattern matching. Like
Pattern
everything is just
match.
pattern matching. Yeah. So I just want to spit okay. So this is the poor man
Wait,
kind
wait,
of
wait.
like
I already have a
result.
question. I already have
Yeah.
a question.
Okay.
So, are you saying like expression is a value, right? The expression f below the no, not below, before the arrow. Before
Before
the
the
arrow,
arrow.
yeah.
This.
So this is what exactly?
this is
This
the
is
parameter,
a
man. This is like
this
the
is a
S
yeah,
in
this is
OCaml or the
yeah,
at Haskell.
like I don't know, you have this and then you do I don't know, this ABC S X.
Yeah, but
Something like
x
this.
is x the entire tuple?
Yeah, like in
Yeah.
Oh,
Haskell,
okay.
This is
the
everything.
Oh, okay.
This is
Okay.
just to okay. I want to match by this condition, so just rename it
Yeah,
to me.
rename it. Okay. No, no, no. Okay.
So we gotta end things by this dot. So that's it. Eval with oh man, I type so much faster here, which is not that fast by the way, but I type faster. Okay. Oopsie, we need to end with comma with column
Semicolon.
because semicolon. Yeah, because we still have more definitions of this function. So you end with semicolon.
And this is a variable, Nathan.
what?
Yeah, this is
No,
like if
this
you have an
What is
x
a variable?
a variable
hang
is
on.
a label. Actually,
Yeah.
this is a terrible name. Let's change it
No,
already.
man. What do you mean
No.
by you said this is a variable? What is this that you mean?
This.
This
Oh,
this is the variable part. No, but you're
Yeah,
right.
this is a
This is
lambda
a variable.
calculus
Yeah,
variable.
yeah, but this is correct. This is not. This is correct. This is a variable.
I don't know.
This is a
And-
lambda calculus variable, man. A literal,
The
not a
thing
literal.
called variable is not a variable. It's a
Yeah,
name.
it's a label.
A symbol, like
Yeah,
no, I just call it variable, man.
We are calling variable here because we are trying to find it in a map.
Yeah,
oh, okay. Now I see.
yeah, we are doing a find
No,
on the
but
name
it is variable. It's just that.
with the environment.
Yeah.
And then I just say, okay, I cannot find the variable in the environment. We can
Yeah.
put better error messages later, but that's
And
it.
let's
some
let at
point.
least let that let how can I say that? Let's
Let-
at least put the name that we are not finding already, man, because that's too easy, isn't it?
No, yeah, okay. I just want to break, man. By steps. Let's do by steps. So we care about the environment here. So let's do environment this. And we don't care about the expression. So we just do this. And then we have this. That's it. Then again.
Oh, and by the
eval-
way, I think something important, right? I don't know if Nathan already noticed it, but there's a differentiation between like a normal abstraction and an abstraction that is like ready to
be evaluated.
Yeah.
With the closure.
Yeah. This is a Magetta thing.
No,
So-
that's not a Magetta thing.
Yeah, it is because I already saw interpreters without this.
No, sure, you can do without closures. You can do the rewriting and alpha renaming thing, but it's just a lot harder to implement.
I don't know. I saw it. Well, I saw a
So
few lines of
harder.
Haskell. So well.
Oh man.
Okay, so this one we just get the entire expression, so closure.
And you can, if you have any questions, Vinicius, please ask me.
That's it. So that's it.
That's a dot or is that a semicolon?
Okay.
That's a dot because it ends here.
Closure.
What is ending?
Dot ends stuff.
Ends.
Comma?
Yeah.
Comma basically gets a bunch of expressions like an end in Prolog. That's why Erlang has that.
Wait. So you
And-
are done defining the eval with environment pattern matching.
Yes.
Oh.
Yes.
Okay.
So if If I put like
Yeah,
this,
that's
then
cursed.
it expects me to add another one. You see?
Yeah.
Like Emacs already is smart. Like if I just add this, it already adds a new one. You see?
Wait, why do you
Oh.
need the closure case?
Oh, the closure case is just propagating. And
It's
just
something that will
wrapping an
never
OK.
happen in practice.
And
right?
just wrapping an OK.
Okay, what I mean is that will never happen in practice, right?
You will.
How?
It will hit here. If you
No,
pipe any
you are
other
calling
thing.
evolve passing a closure.
Yes.
I'm starting to think that it will not, Mageta.
That you will not for
Fine.
sure.
You know
And-
why?
Why not?
Look-
This is
look
the
at- Look at the pattern, man. Can we agree that all other
Dude,
patterns
I
they have
am
a tag?
evaluating
No, no,
closure.
take a look when you are parsing the thing. When you are parsing the
Wait,
thing, you
wait,
will
wait,
spit
wait,
an
wait,
expression, right?
Let me
Will
see.
that
Hang on.
expression ever include any closure expression?
Eval
No.
with environment, and then I pass the body. Yeah, I don't eval the closure.
So can we?
Yeah,
since we don't
it
have
could,
exhaustiveness
like,
check.
Yeah, it doesn't matter. Whatever makes you guys happy.
Well, let's go to TypeScript then.
No, that does not make me happy. Certainly not
Okay,
my
I
case.
got the implicit guard there.
This one, I think we can keep this case. I don't think it's a problem.
Evolve closure.
Oh, this is cursed, man. Like, because in, like, for example, you could do this, right? Like in, I don't know, F sharp. You can do this and assign some bullshit here.
Hmm.
By the way, this is valid here.
That's a
Um,
symbol, right?
yeah, that's a symbol. It's an atom.
Oh, okay, no, it makes sense.
But like, you cannot assign it again. Like if I try
Oh,
to
yeah.
do-
You
yeah,
cannot do
So-
shadowing, right?
yeah, which is like okay, like it understands as like you're trying to mutate something. That's
Oh.
but anyway.
Oh, but I don't
and
understand
just-
this thing, man. Like, what is the? Where are
Okay,
you
so
using
this
the
is
evolve
basically-
closure?
Wait. I think that we should always start by line 12 down, like evol, right? This is the entry
Down.
point.
Okay,
This
that's
is
fair.
the entry point.
That's fair.
Okay, and then we call the first evol with environment, passing the environment empty, and the expression that we're trying to evaluate. That would necessarily pattern match, or it should pattern match, one of those four. Okay? And to get through the other functions, let's suppose that this is an application. Okay, let's suppose that we are trying to, on the eval, we are trying to evaluate an expression that is classified as an application. Then we're gonna call eval application. That will go to the eval application there. That will call eval closure, and then we're
Oh,
done.
wait. Just go a bit slower, Lemos. I am
Okay.
not that fast. Here.
Okay. So let's.
Eval
Can we
application.
agree? Let's suppose that we have an application to evaluate. Then do you agree that we're gonna go to 6 up? Okay.
Yes.
Okay. Nice. Then we're gonna call eval application.
Oh, just one thing, Mageta. The thing there, it's kind of a thing. Like on the eval with environment on the application, you name the thing value, but it's not actually a value, right?
Let me see.
an
Wait.
expression still.
Line 9 down.
No,
6
6
up.
up. 6 up.
6 up.
The places where
Value.
you
That's
have
a literal.
value.
Yeah, that's a literal.
No, that is not. That is an expression.
Not necessarily is a
It
literal.
has to be.
Well, otherwise it
okay,
fails,
no, it
but
doesn't.
it can be
It has
an
to
arbitrary.
evolve into a literal.
Yeah. So,
At that
We-
point, it doesn't, but it has to evolve down to a literal.
yes.
It can be an arbitrary.
Okay, and then we're gonna call eval application Atan. We're passing the environment, the abstraction, and the value.
Mhm.
That will go to 15 down. And then
Yeah.
there let's suppose the happy case. So we're gonna pattern match with an OK, getting a closure. So something ready to do the substitution. That will call eval closure on line 17 down,
Okay.
and that will call 7 down, which is eval closure.
Holy, I don't think we need this eval closure, man. We could just inline the thing there.
Yeah, but it's really long, man. Look at that crap.
Yeah, I just separated because it would be long.
I don't think so. Most of it is doing the Oh, okay, yeah, the other match.
I have to, dude. I don't want to do this there, like with
Yeah.
like indentation.
That's okay. So we do the eval closure.
Yeah,
Otherwise, we do
and then
error.
and then we have errors along the way. And in the happy case, after we do we get the evaluated value, we put that into the environment, and then we call eval with environment again.
Wait a bit. We evolve. Wait, man.
Wait, where are you?
He's
I'm
in
on eval closure
eval closure.
Okay, so let's view this function.
because
So
the names are a bit.
you get the closed environment, so the environment that is ready to be evaluated with the thing.
Yeah,
old
this line
environment.
1 down is wrong, man. You are evaluating the argument of the application inside
Yes.
the env of the closure.
Closed environment.
No, that's not the case.
This is the environment that is sending to be evaluated. That's not wrong.
No, that's the environment that is inside the closure, and you are evaluating the argument with it.
But the argument that is inside
So
the
take a look
closure
on the
is the
7 down.
one that is
So you see
Okay.
the 7 down, right? You see the name value. So
Yeah.
it's the third argument of eval closure, right?
yes. we
Yes.
saw
So do
one.
you agree that this is the argument of the application?
Yeah.
So this should
So
be
that's the problem.
evaluated in the environment, like the environment that the application happens, not the environment that is inside the closure.
Oh no, you're right. You're right.
I don't get
No,
it
he's
because
right, man.
no, I don't get it because as far as I can tell,
Write some code to picture Magita.
Actually, in this case, I think it doesn't matter.
It does matter, of course it does. You could declare that closure anywhere, and
But
then
you can
pass it to that.
declare a value outside, and then you have a value that you don't like. It's not in the closure, right?
can we have an example of
It
this
has
on the
an
screen,
error.
please?
Yeah, can you do that? Magita?
Let me run. I think it was this. Yes.
No.
So-
Go to the editor in a blank line and just write an example.
Yeah,
That's
just
it.
any
Yeah,
comment
that's-
there.
Dude, I was going to run the thing.
Well, okay, you can.
Okay, you can run.
Eval dot. So let's
Oh
make
no,
a
wait, you will
thing
do
here.
no, man. Just write like camel code or something. Like it's much easier and faster.
It's the same thing, man. It's gonna be a record.
No,
It's the
it's
same thing.
confusing if you are writing the ASC there instead
My
of actual
dear lord, man, it's the same thing.
code. It
I'm
is-
almost sure it's not Mageta, but go on.
It's the same garbage. I will write here right now. It's the same garbage, man.
Magneto writes F# in the EST instead of using the.
There's
It's
no
the
way he
same
does that.
garbage.
he's saying
let's
the
do
same.
let's do an abstraction that replaces the thing. So it's got to be an application. An application has what the abstraction. Then the second thing is a theme is just the label, right? So you can be in like an atom.
Wait, Mageta, wait. I think that's the point. Instead of showing the AST version of the representation, let's suppose that we have the
Real
we have the
code.
code. Yeah, the real code.
Okay, so
before
give me an example. So give me an example.
Camel.
Go.
Do the same, but in Camel.
No, tell me
Correct,
yours. I don't want to do mine. Okay, Everything
so,
you criticize, so go.
I will just type here, man.
Why are you so pissed?
I'm pissed, man, because this is stupid. Go.
Why are you so
Okay.
pissed?
I'm pissed, man. I need to be pissed.
So take a look on the.
We're gonna be very
the
pissed on
comment
this
lemon.
entire series, by the way.
I think
Can
it's.
you hear me?
I don't understand. I really don't, but okay.
Let me
So
see.
we can see the comments, right?
How
So-
this is the same thing as the ST? Mageta is crazy, man.
The same thing, man. You can see the same garbage. So
You
okay,
have a
this.
different set of eyes, man.
Ah,
I'm sorry.
okay. So x takes into x plus 1, 2.
Yeah, can you guys define me what is the closure environment
Okay.
in the environment?
So you are seeing that this expression is an application, right?
Yes.
Okay, so the application is expression. When we evaluate the right one, in this case, it gives you this value, right? And when we evaluate the left case, it gives us a closure, right?
Yes.
So if you take a look on the left, the closure will contain the environment in which this application is in. Do you agree?
Okay. Yeah.
So this environment that the closure has, Magenta is using that to evaluate the argument. In this case, it doesn't matter. But in other cases where
No,
this...
I was. Here's what I was thinking. I'm getting this thing to evaluate what is within this closure, which is the environment that this thing should
Yeah.
have. And then I'm saying, okay, what represents the value that I want to evaluate in here? So I can just replace the variable.
Wait, aren't you talking about evaluating the body with the closure environment added
Yes, the body.
argument?
Yeah.
Yeah, the
That's
body.
not what you are doing right now. We are doing the argument. And
I'm
in
not
the
quite sure. So we have the closed environment, which is the body. No, not the
No,
body.
no,
Sorry,
no.
it's not the body. It's not the body. It is the inside parentheses in that case.
The
I guess.
environment inside the closure.
Yeah. So we have the environment that is outside of those parentheses. We have the value, which in this case would be the number 2, I guess. We have the label, which is going to be x. And we also have the body, which is going to be x plus 1. That's fine? Is that fine?
Yes, except maybe for the closed environment part. You said outside parentheses, right?
No. The closed environment is within the parentheses.
Oh, okay, yes.
Yeah. So how you do this? You put into the what we are doing right now, at least. On line 3 down. 3 down, we are picking the global.
No, wait, but I don't think it makes sense to talk about that if we have the 1 down that in that way still.
Oh, okay. So
the problem
you are
is on
asking
the 1 down.
You are asking that we should not evaluate the value 2.
He's basically saying you should do this.
Yeah, I can agree with that. For me, it should be closed. I'm not getting.
Yeah, in the example that we showed, they are the same. But imagine if the function is declared elsewhere and it has its particular environment. Doesn't make sense for the argument to be evaluated in this environment, but in the environment that the application is being done.
Okay, convince me. Congrats. See, Maggot, you don't have to be pissed, man.
Man, I'm pissed. I am pissed. Because this
Why?
could be... You could have just given an example and it could have just run. It would be a lot faster.
I disagree totally with that.
Oh,
but
man,
anyhow,
no, okay.
I
never
agree
mind.
on the point that it will be better in the sense
Okay,
of
man, okay.
we can
I don't
inject
know, man.
something, right?
Okay. Let's just ignore this. Okay, so then you just get the closed environment, the stuff that you have in there, the environment, then you merge those things with the new label and the new value evaluated. You merge those two things, so the closed environment with that thing, plus the environment. I call it new.
I'm not getting it.
What
what
we're doing
is
is
the
the following.
maps put?
The maps put is picking
Adds.
a map, which
Yeah.
is the closed environment, and it's adding a new set of key and value.
Mm-hmm.
Yeah. And then we are adding that to the
We're just joining.
global quote unquote environment with the merge.
And then
I don't agree with the merge though. I don't think it makes
Why?
sense.
Why
Because
is not a merge?
You evaluate the body of the closure with its environment plus the argument. It has nothing to do with the environment of the application.
What? Say it again. I didn't understand.
Okay. So the way you evaluate the closure is evaluating the body with the environment of the closure, but you extended the environment of the closure.
No, wait. This... Okay, we're evaluating the body with the environment of the closure plus the environment that is outside the closure.
Yeah, that's the thing. I don't think it's needed and might be wrong. Like, might cause some errors.
Why?
Because that's the thing, man. What are you doing in abstraction? You are doing the thing, abstracting.
Oh, okay, I see what you're saying. Like you're just considering me having like a global value. Is that it?
This
You're just
considering to have a
looking. You're
global
just
value.
looking at like declarations inside abstractions.
Looking at declarations inside.
Yeah, because if you're looking at like a declaration of a declaration
No,
and
but
saying
wait, it also
like a
captures
values should
the
be also always bound. Is that what you're saying?
values should always be bound. No, we
Yeah,
cannot
because
guarantee that. We cannot
no
guarantee
man,
that
I'm
the
not saying
variable.
that you're. I'm not saying you're not gonna evaluate something or get an error. That's not what I'm saying. I'm
Mm.
saying that uh, we don't have the possibility to have something outside. Like for example, have out of scope of this guy, right? We don't want to guarantee the case that you declare something outside and you want to use a thing that is in the environment from another like function. You just want to use the abstraction. Is that it? Because I was thinking something like do here. So lambda x.
Oh, that looks like no, no. I'm not messing with, not messing up with you, but it looks
Please
like
stop.
JavaScript in the
Please
sense
somebody
that
stop.
if you declare a variable that doesn't exist, but when you are applying it exists, then I think it gets from the environment. But
So that's what I was talking about. Like I'm merging the environment because I want the environments of the things above that are outside the closed environment of this thing.
yeah,
Yeah, that's a good example.
I
That's a
think
good
that
example.
I think. Wait, you are saying that you want that? Okay, but the environment of the closure already is doing that, Mageta. Because when you evaluate the inner lambda that receives y, you get the environment that has the x.
Is that happening on line 7 up?
7 up.
That should be
No, it happens on the
on
when
16.
you evaluate the
right?
closure. Yeah, 16.
16 up, where I generate the closure. You see? Label body environment.
The environment that is passing through this closure has the x bounded.
Ah. Yeah, so it doesn't make sense to
So
merge them.
the environment that you are merging, what I think would do, and I'm not sure, is you're declaring an abstraction, and the thing is unbounded, the variable that you are using. It's not on the parameter of the function. It's not on the environment of the closure. It's unbounded, but it is
Okay,
bounded on the application environment, and then
So
it would.
what is the point? What is the point of making this closure then?
Hmm? Well,
There's no point in making the closure then.
what we just showed, like that's why.
Can you repeat, Mageta?
Go say the example again, Nathan.
Okay, do Control Z because you had the
Yeah,
closure.
undo. Yeah.
So yeah, that's why we have a closure. Because when you are evaluating lambda y, then x will be bound. It will capture from the
No, I'm
environment.
saying like, what is the point of having the closed environment and the environment here? There's no point.
Wow, let me see. Just to evaluate the argument. In this function in
Just
specific.
to evaluate the argument. No, but now I'm wondering the same question as Mageta's. I think that the closed environment and the environment, they are kind of the same here.
No. In this example that I showed, they are. But not necessarily. The function can be evaluated elsewhere and become a closure elsewhere, therefore a different environment than the one where it will be applied.
Oh, that's correct. That's correct.
Then
So,
the one that will be applied.
yeah, so imagine that we are in the main function, for instance. And then we call a function that is elsewhere, not in this main function. It is elsewhere. In another module, whatever. And then we have the environment of the main function and also the environment of this other, in another module function. These two environments, they may be different, which is correct. But in this particular case, because we have one function inside another, they share the same environment. But this is just a coincidence.
They don't exactly share the same environment.
Yeah, they do, because y have access to x, because y is inside
No,
x. In this
lambda
case.
Yeah, but
x
x
doesn't have access to x necessarily.
No, lambda what, sorry?
Wait.
Lambda
X
x,
doesn't have access to X?
yeah, But in Y, X is already bounded.
Oh, because at this point it's already bound to this. Yeah, it makes sense.
What is the same environment is one that I sent it in chat.
Wait, lambda x doesn't have access to x?
No,
Does that
because
make
this
sense?
Because
thing-
it's not bounded yet.
Yeah.
He's the one binding it. But if you take a look on the thing that I sent on chat, this is the same environment. Because, wow, it is.
Okay, so the closed environment and the environment, they are
Let's see.
different.
Oh, this you mean?
Yeah. So they are different. Okay, we can
In-
agree with on that. The
Well,
value
they
is
can be different.
they can be different. Yeah, that's the point. They can be different. So going back to the example, the simple example. So x plus 1, number 2. So the closed environment, the environment we already discussed, the value is number 2, the label is x, and the body is x plus 1.
Mhm.
Now we are discussing if we should merge the environments or not after it's done. Not after it's done, before calling involve with environment again in for
but-
up.
In the body, right?
Yeah, in the body.
Yes.
And then we're discussing if we should or not.
Yeah, but the thing here will change because it will be okay. I pass down both environments,
The thing would change.
and then I just evolve
you would
the,
still
the
need the
value.
environment in this function, right? Or the value.
Let me finish. So
Mhm.
we pass the value, we evolve with the environment, and then here we do not merge, but we only use the environment from the closure here
Mhm.
with the new label. So it would be
Yeah.
like this.
Map put, yeah, and then but you need to change in, yeah, we can use, yeah,
Yeah,
exactly
I
that.
think that's it.
Okay, now we should test this on the. Wait. Before doing that, let's read eval application also, I guess.
Oh.
Eval application gets an environment, an abstraction, a value, then tries to reduce that abstraction to something else, which is a closure. And if it succeeds, we call eval closure, and then we call match2, which is the best error message humanity made.
Meh.
Okay.
I could
Okay,
raise
so-
an exception as well. Which one?
Okay, so. Oh, are you for real? Rising exception?
I could raise an exception. Like at this point, it doesn't matter anyway. But anyway,
No, let's stick.
Ooh, the good thing is that wait. Can we like accumulate errors or wait?
yeah, we could. I'm not.
Doesn't
I'm
make
just like
sense.
replacing. I'm just propagating. Like, and you see here that I'm ignoring completely. Like I'm not. But we could.
It's because, but that's the, like I know that for parsing, it makes sense to accumulate errors.
Yeah, but here I don't think so.
But for evaluation, I don't even know if it's possible because it failed the evaluation. You cannot continue. So on the first
you
error,
can.
you are done.
Continue. No, you can. You
It
can continue
depends.
to the exit.
No, think about the thing, man. You would fail on a division by 0.
Okay, and then you would
keep
already
going
return.
evaluating, right?
Yeah.
That's
Yeah.
bullshit.
Okay.
No, but division by 0 is a special case because it will
I mean,
trigger
any
segmentation
fail,
fault.
man.
No, not all fails. You can have a fail in C and the thing will still keep going.
What I mean
Yeah,
is,
but we don't want that.
You don't want that.
That's the one we want.
Oh, man.
Okay, so let's go to the terminal and see what happens.
Okay,
Save this, by the way.
See. Oh, it's saved, I think. Yes.
Wait, but do we have? Oh, we have the literals, right?
Yeah, we do have.
Yeah.
The,
So let me just divide like this. Is it readable? If I do like this?
Yes.
Yeah, it is readable.
Okay. So let's do application. We don't have addition, so I'm just gonna do a substitution.
Yeah.
I think.
Ideally today we're gonna have addition, but okay.
Yeah, additions, comparison, and what else?
All the basic arithmetic operations.
Oh, we need to test recursion as well. I don't know if it's because I'm matching in a case, so I'm not sure if we have tail call here.
Oh.
The argument's not alone. Yeah, but okay, let's see. So x, which is just an atom, and then we have a variable that has x, which is the same atom. And then outside this thing, we have a literal. Is it a literal that I'm calling?
Yeah, literal.
Okay. Literal, I don't know. True. Should be true, the value.
Yeah.
Should be true.
And
Yay!
did I call the right guy?
Undefined function
Oh.
eval.
What? So the function.
Expecting true stuff? What the fuck?
No, this seems like we didn't import it correctly.
Yeah.
Oh no, the parenthesis is wrong. Like you are
Evolve
calling with
true,
two
man.
arguments.
Oh yeah.
Move the literal to
Oh.
the left.
Actually, here, right, is wrong.
And
Literal true.
yay!
Nice.
We know how to do it. A function application.
So let me see. Now, if we do just an abstraction, should be just a closure.
Yeah.
Oops, this closure. Okay, with no environment. Oh, it actually prints pretty neat.
Oh wait, can we test something? Let's see
You are
how is
neutral-
that environment printed.
Yeah,
how is
so
the-
So
create.
you can do a partial application. Do the receive
Okay.
X and Y, but apply just one of those.
That's the thing.
Hmm?
That's the thing. Because the abstraction, okay,
You
we
can do
have
the
to
second function.
yeah, on the body, right? So
Yeah,
let's
yeah.
do here abstraction.
Yeah.
Why?
Why?
Variable. Why, man? Oh wait.
Yeah, just return the second. Like,
I put X. I don't know. Whatever.
oh yeah,
Why?
where's the first? Doesn't matter.
Yeah, it needs to be the.
Okay. What
Okay.
is this? Do you
Let me
have
just
parentheses?
so it don't get
Yeah.
mixed. Here.
Yeah, but then you need to apply that. You need to apply
then-
this whole abstraction in a
Yeah.
literal.
This. I'm kind of confused.
Yeah, look, this is the same thing as having a post function. It's the same.
This-
Ah,
If I was doing a terminal with, well, in a text buffer with indentation, everything would be okay. Abstraction, and then I just want to apply a literal 2 again.
Yeah.
Is it right?
Ah,
it
yes,
seems
yeah.
to be right. No.
Syntax error before
Oh, before
Yes.
application. Before application on the left.
oh
Before
parent
appli-
comma. Yeah, comma.
Nice.
Hey,
N-
we have a
oh,
closure.
that's a nice representation.
JavaScript
Oh,
base.
Oh yeah, that's a nice.
Yeah, man, I'm kind of
We have the
liking. I know we were
closure.
gonna suffer. I know we are gonna suffer a lot when things start to break and we don't know where.
Man, type system. When we start the type system stuff, like it will be hard to keep track of everything.
Because let me explain to you, Mageta, what is the roadmap that I suggested to Nathan.
Okay.
So the roadmap that I suggested is calculator,
Mhm.
then variables with like actually I already have variables, I forgot, so forget that. And then immediately after those two, calculator and variables types. And then
Don't
Calculator
we
and
wanna
variable,
do
what?
calculator.
assignable? Okay.
No, but it is already. Wait.
Assignable?
Yeah, maybe I meant that when I wrote that. I don't remember.
Wait, I don't know what assignable means.
It's the normal Grug variable, like the one the mutation.
Yeah, mutation.
Oh, we want that? Why?
Why not? Ref.
Man, it introduces a bunch of problems mutation. Like it's harder to do
Yes.
stuff.
It is harder to
Like
do
it's
stuff.
already hard enough to do type system
let's-
without.
Yeah,
mutation.
exactly. Let's think about mutation.
Yeah, but let's think
later.
of yeah.
Let's so
think
that
of
so calculator and then types. Then,
Yeah,
then
the
that's
other
the idea.
example, Mageta, is that we have the value restriction. One of the reasons is because of mutations, man.
the value restrictions
In like ML languages, like so. How can I?
Wait, what do you mean? Oh, like for example, restrict the type via the context, something like this.
No, it's more
But if
like
the v
you
can
create
change-
a ref for
Okay.
ID function, but
Mhm.
then you could assign something with the same type, but would be wrong. Something like that.
Guys,
Okay, it
guys.
could be wrong on another thing because the type annotation is the same, but the reference is different. Is that it?
I'm not sure. I have to take a look, but it
Yeah,
does
we can
introduce
discuss
problems.
this
But that's-
mutation thing
Yeah,
later.
okay. Let's.
So
let's discuss
calculator
it.
with like
Okay.
at least 4 basic operations like plus, minus, multiplication, and division.
Mhm.
And
Naturals, right? I'm just gonna care
no,
about
that's a
naturals
discussion.
now.
Integers or naturals. But anyway, and later the next step is type system.
So
Okay.
we are only lacking on the calculator operations for now.
Yeah, only
Yeah.
like on the calculator.
Let's try to do the test the recursion before we go.
Yeah, let's do
Yeah.
the test recursion.
So
Should
So
the
how
X
can-
apply
okay.
X on X?
let's make it outside because I'm gonna get
Wait,
confused.
what you said isn't like an explosion?
Huh?
Yes.
Okay.
What do you mean explosion?
Because I think you said the omega combinator, if I'm not mistaken.
Yeah, but what do you mean with explosion?
Like recursion. That's what he
Yeah,
means.
yeah.
But that's not explosion if you have the.
Yeah, but
Yeah, the meaning, my Geta got the meaning, thanks.
Yeah, it's not like exactly an explosion. It's just like infinite recursion. That's it.
Yeah. We get that's what makes the omega combinator so cool.
Okay, so remind myself. So it should be something like. Oops, let me do it here. So it should be. Oh, let me do Erlang instead. And can I comment? Yes, I can. So it should be something like. Let's do Nekoma here. Fun x.
X.
That
X applying
applies x, which
On
is
X.
also a function.
On X.
Apply x.
Yeah.
That's
And then here we
just
need to
copy and
pass
paste.
this.
Yeah.
This. Okay. This is evil.
Oh yeah.
Okay. So we're gonna do.
Actually, I don't
an
classify it. It's
application.
evil. It's just
Me neither.
incomplete. It is just incomplete.
Evil. Okay, so we're gonna do application.
What do you mean by
So
incomplete also?
Yeah, because the next step
Application.
after having the omega combinator is to add a function to transform it to the y combinator, and then it's beautiful.
An application of. We just do because it's gonna be the same thing, right?
Yeah.
Yes, it's gonna be the same thing. So an application of x over x again.
Yes.
But what do I put in x here? It's not a variable.
Wait,
Is
wait.
it?
Can't you put
Yeah,
in,
no,
a,
it
in a
is. It is a
variable?
variable.
Like, can you put one of the sides in a variable and then just do application of X on X?
At times like this, the VS Code would be useful.
Why?
Because you could just do instead of spelling. It's
Yeah.
harder to understand.
Oh, okay. Okay, so you have the two sides, right? The two functions and they are the same, right?
Yeah.
So do the AST for one of those and attribute to a variable.
No, but
Yeah,
An
imagine-
Erlang variable.
Imagine the following, Magetta. Instead of doing the comment, the second clone, remove it and put the number 2.
Huh?
Yeah.
Wait,
So the
what?
second clone of the omega.
this? No, I'm
Uh,
ignoring this, man.
oh, okay.
Like,
So then.
what
Okay.
about this? Like
Okay, so this
this,
is an-
I should be an application of a variable that summons the same guy.
Yeah, on X. It's X again.
So variable x, that,
Oh, wait.
because that's wrong. Like it's not a variable,
No,
but
no, yeah,
it
but-
kind of is.
Wait, is application of X on X? Like the
Yes.
argument is X. And for the other expression, like beneath, you can just copy and paste also.
Copy. So this should also
Yeah, X,
be
that's X.
an application.
No, that's X.
So variable x.
No, yeah, both are variable X actually. Also, the first argument of application is also variable X.
No, but this is an atom.
Yeah, but that's an application there. You are not passing a label to an
Oh,
abstraction.
okay. Yeah, that's stupid. So, okay. So this is gonna be an abstraction.
No, that's
No way.
variable X.
That's
Variable.
Yes.
Okay, because it's gonna replace with that. Okay, makes
Now
sense.
it's the same thing, right?
Wait.
As the
Oh
other
no,
one.
makes
Yeah.
sense. Oh no, now it makes sense. This
Yeah, that's right.
outer application crap. Now it makes sense.
Okay.
Abstraction
now-
of X has the body of an application of X in X. Okay.
Oh, we don't have anything to print, but it didn't explode.
Are you sure?
Oh, yeah. I killed the thing.
Yeah.
Oh no.
Yeah, but let's do something to show like
Let's
can we add the
run. If
print?
it doesn't do anything.
Yeah. Let's just no man. No print. Printing will be bad.
Why?
Oh. Oh no. This is
It doesn't
not.
matter.
This is an
Oh, it doesn't
interpreter,
matter.
man.
Alright, this doesn't matter.
So where's the eval application? No, okay, here. So we are creating a closure. So let's do inside the eval closure
I
here.
don't know.
Yeah, for me, whatever.
For me, whatever. Oh yes, yes. On minor model.
What is the Yas?
So now I have like this, and then I can just type the stuff.
But what Yas stands for?
I don't know, man. It's just an Emacs package I use, and I don't know the name.
Oh, man.
It's for like extensions on a language, and I think it is what? Wait, my keyboard is acting crazy. This, and then the second thing is this. Oh no, go back, and then okay, actually we don't need to print anything. Let's just do. I think I need this though. Oh, why did I wipe out here? Let me swap my keyboard mode because I need to type this evil thing. Okay. Now, eval. That's it. Oh no, we lost the thing.
Hmm?
Actually,
don't you
no,
have in a
never
buffer?
mind. Yeah, we do. Thankfully, it did that. Oops. Scratch.
How safe? Scratch.
Oh yeah, we know, right? We know how safe it is. Oh yeah.
Yay!
Yeah, I think we do the theoretical optimization in Erlang then. Do we have
No,
loops in Erlang?
then we do. Oh no, you can make your loop. You need to make.
Shouldn't
yours.
you kill that?
Hmm?
Yeah,
Well, you can
It's
let
pretty-
it running, like it's pretty.
Hey.
it's pretty.
Oh, right. I don't have the thing to terminal to show this thing. Yeah, I mean. No,
Oh,
it's-
that's a win for Erlang, man.
Yeah.
Because
I
common.
was just concerned because I was doing inside a case. You see,
I don't see the problem.
the problem is that this is not an expression that you can tail.
Oh, okay, but that's the thing. Every single step, you are not doing the tail recursive, but you just builds up a bit, and then you do it. I don't know which step exactly.
Can you guys explain to me a little bit further why this is like a challenge and like if this was not happening, if we don't have the infinite loop going on, what would that mean?
That would mean that it's replacing things in the stack. No, it's not replacing like the last position in the stack by the new. So it's just adding a new position in the stack.
Like
Mhm.
Lemus, you know about TCO, right? Tail call optimization.
Yeah.
So yeah, we were just concerned if Erlang has it or not.
Yeah, but what if
Yeah, because
if the language
Lisp
doesn't
doesn't.
have
If
no,
it
but
doesn't have, then we cannot
Like
evaluate this.
Lisp. Yeah,
Yeah,
we need to
Lisp.
convert this to like a loop.
Oh man,
Lisp is the cursed thing.
we need to convert it like a loop.
Hey man, we had.
No, yeah, that's it.
Oh man, how can I say that? We should have taken a look on that before, man. Otherwise, it would be really sad.
Well,
You only live
I would-
once. That's the philosophy here. Okay, so what about arithmetics then?
okay, so let's just do.
No,
So
and let's
we-
also change the error messages because I'm getting triggered.
Oh yeah, okay.
The variable
So
is
what
the
should I put in
easiest
here?
one.
So what should I? Let me remove this.
Okay,
What
so
should I add in here?
couldn't evaluate label in the environment. I guess
No, that's
couldn't
no, what the
evaluate.
fuck? That's
No,
a
wait.
terrible name, man. What the fuck?
This,
It is pretty similar to the first one. Could not find variable in environment. What are you talking
yeah.
about?
Unbounded variable X. I think that's the better one. But label? What the fuck, man? Label?
Yeah, because it is a
No,
Unbounded.
for the
in-
user, it's not a label. It's a label for us.
Let me see.
I disagree.
We
In
can
Lambda calculus, the formal name of this is label.
No way, man. Can you send me that?
So how do
Uh,
we format a string here? I don't know. I think it's L.
Sending references about
Format.
calling this a label. What do you call this, Nata?
Well, variable?
Variable doesn't make sense because it has a connotation of memory.
Huh? It
Yeah.
doesn't, and you don't have memory in lambda calculus.
That's why Harper calls them assignables.
That's a
Oh.
better name than variables.
Oh,
for
yeah, yeah, indeed.
So let me
Sure.
read here.
I guess
So-
church call it label,
No,
but I have
wait,
to
but
check.
doesn't the assignable implies mutation?
Yes.
Oh, then it's bullshit.
That's bad.
Yeah, that he calls
That-
variable the normal substitution variable, the math variable. He calls assignable the mutation
Oh,
verbiage.
okay. Then he used variable for the lambda calculus and the actual implemented
Yeah.
thing.
Okay, let me see how church defined this crap.
So writes format returns an
Variable is
OK.
terrible. Yeah, assignable is
Maybe you will
just
find variable name, man, but I don't think you will find.
Do I have
Label.
Erlang? Oh wait, we have Erlang here with the Let's save spoon
well, according
Okay.
to Wikipedia, nothing's correct.
format.
They do call this
Now
crap
that's correct to
variable.
what, man?
Calling this variable, which is a bad name for this.
Oh,
How
this?
can
Yeah.
it be,
That's it.
man?
The grammar
Because
is basically
variable has a connotation of imperative, man.
Huh?
No, man. Today
What the
it has,
fuck?
but like it's a math variable. You should
Oh, a
think of it
math
as a math variable. Yeah, which is like a plug, like a hidden charade.
Wait,
thingy.
don't you call variables in Haskell? What the fuck do you call it then?
Label, of course.
No way.
Oh man,
Yeah.
no, that's
No
cursed. That's
way.
cursed.
That is
Of
no
course
way,
I do.
Lambus. Really?
Yeah. Yeah.
Holy fuck, man.
That's how I call it. I'm not saying it's how everybody calls it.
No, okay, but yeah, that's
Because-
cursed, Lambus.
For me, it makes a lot more sense having a map between a label and an expression than anything else. So.
Mm.
Okay, so this thing can format a thing, but how can I
Wait, what
capture
is this?
that?
Oh, X, okay. Because you don't have like the new line. And they don't
Yeah.
differentiate how to print the symbols. Oh man, what the fuck? That's a bit sad.
Is it like this?
Wait, what are we
I
trying
just
to
want
do?
to capture. I want to capture the format, but it always. But I think it's just this. Let me see. A equals to this, and then we can do A.
Mm.
Okay. No, actually, it's wrong.
Wait, can you explain to us? I'm not
I
getting
just
it.
want to capture. I want to format. I want to be able to format something, so we
Oh.
can do the stuff with error messages,
Oh,
like
okay.
unbound variable, like in the
Do
name
we
of
have
the
simple
variable.
concatenation? That would be okay also.
I don't think so.
Oh. Wait, is X a string?
No, this is an operator for thing. Do we have strings? Please don't be like C strings.
Wait, isn't that a string? The for up?
Oh, okay. We have string concat S1.
Nice.
So
No, but you need to check if this is doing mutation, Magid.
Huh?
no, nothing does mutation. in
Strings?
Erlang, man.
What the that would be. Oh man, that would be quite a thing.
Okay, so it does. Okay, the good thing about I don't know if I say
Wait, are they
good
doing
thing
the
about not having a
conversion
text system.
of symbol to string already? They are, right?
There's, I don't. Yeah, I assume they are.
Yeah, like I think they
Unbound
did on
variable.
the X there that you pasted on the repo.
Unbound variable, and then
And we don't have the informations now, Lemos. But when we have the parsing, our AST will change because they will carry information about lines and stuff. So it will be unbounded variable
What is-
X on line and column X and Y.
Yeah.
Why is this wrong? Oh, it was not. Okay. Just needed to save.
Okay, so
Okay.
copy paste this, and then we can go to line 9 down. This is what?
Mageta, how do you represent the arity of variadic functions in Erlang?
Good question. I don't know. Do you know
Because-
Vinicius?
Because
You're asking
concat
me?
is variadic, right? I think Vinicius is
Vinicius.
not here.
Oh, Vinicius is not here.
Oh.
He went to dinner. Okay, so
How
what
to
about the error
represent
message on here?
arity? I have no idea, man. But I think it's not a problem if you have if there is such a thing as variadic argument function, because you can always
I
do pattern
assume that
matching, right?
concat would be, right?
What if it's not, Tanta?
Well, then they implemented. Oh man, maybe they
Mm.
don't have implemented for like 3, right? Oh,
Yes.
that's just sad then, because we would have to nest it if we want more concatenation.
Yeah, and that would be
And
terrible.
then we do need the format because
Yeah, but you see this, like you can pass 2, then you have arity 3, and so on.
yeah, but maybe they just expect you to pass a
Equal
list.
4, 3. Yeah,
Yeah,
that's what I'm saying. Like you,
probably don't
you
have.
can always just pattern match. So I don't think it's a problem. Like here, for example.
We're
No,
gonna do a lot of
you
better
don't need
matching, folks.
variadic functions.
Yeah, like-
it's just
like
that,
that.
right?
Does it work? Let me see. Probably not. Yeah, it doesn't because there's no concat 3. But what happens if I do this?
That's quite a thing, right? Because they don't really have
Yeah.
reasons, I guess. Because
Uh,
despite
yeah,
Lisp
anyway.
don't needing to represent the arity, they have. But they also have the variadic functions, right?
unbound variable. What about this name, Nathan?
What do you mean?
Uh, Well-
On the closure.
yeah. What you gonna?
eval application?
If we have an error evaluating the value inside a closure, what should we say to the user?
Wait, man. We tried to evaluate the argument, and that was a problem.
Could
Well,
not evaluate.
we just returned what we got.
What?
Yeah, because involve with env,
Okay, yeah. It's another error you're carrying down. So
just return, right?
actually, we can just do error.
Shouldn't we say that we couldn't evaluate it further or something?
No, like
That sounds really bad.
No, it is not, because take a look. Involve with env is getting the adequate error already for evaluating this argument.
Oh, I see.
There we can give an error. Because,
Yeah.
well, you cannot apply something that is not a function or something like that.
Yeah. So, okay, we can ignore this. Error could not apply the following value because it is not a
Hey,
function.
we need to decide
Ah.
something, folks.
Mhm.
What should we evaluate first? The left
Okay.
side of the application or the right side of the application?
You mean with like a sum,
Huh? No,
like
no,
adding?
no, application.
No, like you have like left and right, and what do you evolve first?
Yeah, because in this case, we are evaluating the left, right? So one consequence of it is that we have more than
Wait.
one consequence.
Wait. So we are talking about evaluating to the order of what? Sorry?
Okay, take a look on the chat. You have X
Taking a
and
look.
Y.
Yeah.
So you can see that that's an
I'm
application,
I'm
right?
literally printing an abstraction here. How would this work?
Holy man, the user would
This-
not like.
Let me see how
That
how
can
we
go
do.
wild, man.
It will.
Yeah, that's just the
It
thing.
will.
We cannot do that at compiling the language, but using the interpreter we can.
So let me just grab this and see how.
But Lemus, you are seeing the application of X and Y, right?
Wait, are you asking if you should first evaluate X and then proceed to getting the Y or something like that, or the opposite?
I think so. Not sure if you are thinking about the same, but we
Yeah,
have
because
to
my first
evaluate
impression
both
is-
because
My first impression is that okay, I have the option of first evaluating Y, then passing that to X, or
no.
not
You have to evaluate both before doing anything, before doing anything useful.
Okay.
But the thing is, as things can fail, and we have side effects, then it makes a difference in which order do you evaluate. So what do you guys think?
Left is okay for me.
Okay. So right now we are doing that. And
Yeah.
if it fails already, then we don't even evaluate the arguments. I think it's okay.
Okay, so let's start adding.
How? Wait, just a second, Maget. How do you know, Nathan, that we are evaluating the left here first?
Wow, because we are evaluating the how can I say? Wait, let me. There,
Oh, we are
line
focusing. We are
11 down.
focusing on
Yeah.
having. We are focusing having the closure first, and then doing
Yeah. If it,
then okay,
and if
yeah,
it's not a
okay,
closure, like we cut it already, right?
yeah, yeah,
Mhm.
it's already done. Okay, so go on, Mageta. What you're talking about?
So I was talking about arithmetic. So
Yeah.
we should have another structure. So let me do like
By
this,
the
and
way,
then
I
you
think
guys.
we should change this literal thing, man, because when we have like booleans and stuff, then it doesn't make sense to call everything a literal.
Then we have a problem. Atom.
Well,
No, just
yeah.
call it like a int, right?
Okay, you want to name them. Is that it?
Yeah.
Yeah.
Okay, I was thinking of doing like literal and then wrapping them.
Yeah,
But
but that's
okay.
nested as fuck, right?
That remind me of the go meme.
The fetching exceptions in.
I think it has some benefits. The benefit is if you are only caring if it's the thing is literal or not, you have a better way to do pattern matching. But usually you care about what
Okay.
specific one it is. Then you will have always the nested thing. That's
So we want to do something like, let me comment this, like arithmetic. Oh, by the way, let me copy this thing first.
oh okay.
Lessons learned, folks.
Lessons learned. So let me put it here.
I'm back, people.
Hello.
Hello,
Right.
Vinicius.
So
Just to
we
give you
want
some
to
context,
Have
do.
you
Vinicius.
done?
Yeah, we finished the. Let's show him.
Oh,
It's fast.
evaluate.
Yeah, just evaluate the omega operator in the simple application, whatever.
Let me just add the print here again.
Lemos, we can do something else maybe today if you guys have the time. We can implement native functions. They are quite easy to implement.
Yeah, okay, if you
Okay.
have the time. So Vinicius, what we did, we finished the interpreter with the current abstractions, like abstraction, application, variable, literal, and we tested if it has tail call recursion.
Oh,
So it should be able to do infinite loops using the omega combinator. And it worked. And now we are happy because we just discovered that we should have tested this before choosing the language.
Oh yeah.
Yay.
And yeah,
Oh,
yeah, so it works.
yeah. All right. So let me.
And now we are discussing how we're gonna do arithmetic operations.
Yeah. So I was thinking of this. So arithmetic to hold the thing, and then we need what? We need an
Operator?
operation. So operation, and then the kind. So we can just pass like a plus. Okay, is this a atom? A valid? No, this is not a valid atom. But we can do
That
this as well.
sucks.
Yeah.
Or this is a string.
Can you get the type of
Don't
it on
know.
the repo, like somehow?
We don't have types, but I guess.
No, you do have types. They are just not.
Well, every language is typed, right?
Yeah, in
Yeah,
some
How
in a
do
level,
I
yeah.
sense,
do
yes.
that? Okay, this is valid. We can do this.
Yeah, that's fine. Something that I also want I'm also thinking about
Mm.
is what if you have an operation that is not
What?
like with an
What the
arity
fuck
of
is
2.
this, man?
Like, Lemos, we have a few
What
options,
the
man.
fuck?
So
Okay, I don't
the way
understand what's going
Mageta
on.
is proposing there, it's like doing a node for arithmetic, and then depending on the operation, we have like uh different arguments, right? I don't think that's a problem for Erlang because types,
Yeah,
right?
we
You can do
yeah.
whatever. How many arguments do you want inside the arithmetic?
So this
Yeah.
could be an array, right? An array of literals.
No, what I mean is
So
you could do the
integer.
suppose the minus on as the prefix operation, and that could be on the arithmetic. Even though you have add, that add has like two, no?
Wait.
But
I didn't get how you're gonna solve the
Magenta,
problem. You forgot a
Mhm.
comma.
you need a dot on the repo.
A dot. Yeah, but I added
Yeah,
man.
the final
That's the
dot
thing.
should make the sentence
Yeah. So my
work.
question is, Nathan,
mm.
how we gonna know?
I added
Actually, we're
this.
gonna know because we're gonna pattern match, so that's fine.
Oh,
But I did this. You see? Like I'm just going
Mm.
back.
wait, what?
So my question
Yeah.
was, Nathan, how are we gonna know the arity of an operator?
Because of the operator. If you know the
Yeah,
operator,
and that's the thing. That's the thing that I just like reminded
Yeah, but
myself. You're gonna pattern match, and then you're gonna know.
yeah.
So who
yeah,
cares?
but that's the thing. We can also do in other way, Lemos.
We
Uh,
forgot a comma, Magita.
Oma.
Where?
Before the 3.
Before the 3? Oh, here.
Uh,
Go,
Commas,
Nathan.
man.
Oh,
I hate them.
yeah, but that's the way he's proposing. But we can also do in other ways. So, for instance, instead of creating a node for arithmetic and then do the nested operation, and then we have like different RVTs, what we could do is create a node for binary operations, and then we can use that for plus, for logical stuff, you see?
Mm-hmm.
And then we can treat in other ways. I think it's more sane because some things you do are common. So, for instance, for all the binary operations of arithmetics, you can just evolve both and then see what you have, right? We only have a few cases that you don't want to evolve both when it's a binary operation. That would be for like the ands and or, right?
No, wait. Depends, right? It depends.
No, it doesn't. So if you have sum and other arithmetic binary operations, you can evolve both and then match the operator to see what you do. Do you agree with that?
Yeah.
That's not the case if you are doing an AND. You need to evaluate, check, and then you see if you evaluate the second or not.
Are you sure this is not a
Yes.
lazy exclusive behavior?
No, this is lazy. Oh man, it's fucking hurting here. Yeah, but restricted language have laziness on these
Oh,
operations.
so they do have in some operations.
Of course, the if, man, the if is lazy. What do you mean?
I never used in any. I don't remind
you
any
use
loaded
that.
language.
F sharp. What the fuck are you talking about? You use
I
that all the
never.
time.
Wait, I used an if in F sharp when I was working with it. I don't remember.
Good question. I don't remember using a if in F sharp.
Yeah, exactly.
I don't know what you guys mean. I sure did.
No, man, I'm joking. I'm joking.
But yes, in
good to know.
strict languages, the if and the are they
But
logical
folks,
operators? I
Yeah,
don't-
logical operator.
Yeah,
Yeah.
they are lazy
see.
in some way.
Application variable.
Okay, I think we
Let's
can
see
again.
the evaluate inside the body. Okay, so let me think here. Focus, people, focus. Otherwise,
Yeah.
we're not gonna do anything.
Yeah.
So it's when we start to evaluate the body, right? But that's the thing, it's not exclusive to the body, right? That we want to evolve arithmetic.
I don't know what you mean. Like that's just an expression. Oh, so you
Yeah,
just
so
match in the evolve
where
with the environment.
I'm concerned of where we're gonna trigger the evaluation of arithmetic.
Well,
here.
evolve with environment, you will match something that is an arithmetic as you are calling it, and then you call the evolve
Yeah.
arithmetic.
Yeah.
Ah, okay, I see. So evolve with environment.
Then
Yeah,
the
I'm
environment
just
matters in
gonna-
this case because maybe you are doing x plus
Yeah.
2.
So arithmetic.
Yeah.
And then here you're gonna pass.
For compilation, we can
now.
do a clever thing.
I think
Man,
we can ignore.
If they are
Man,
literals, you can
I can-
just do the computation and
Let me
I can
see,
already
let me
see that these lines
Let's do
using atoms
addition
they're gonna be huge. Huge.
what do you
Yeah,
mean
sure.
lines using atoms?
Yeah, because we can't wrap one thing into the other, right? Right?
Wait, you are
So-
saying that you cannot break after the arrow?
No. I'm saying
What?
that at some point in time we're gonna have a match, like a pattern match,
Mm.
that the line is gonna be huge, like matching a bunch of stuff.
Yeah. So that's the thing. Why don't we go with a more flat structure in the AST, man? I think that's better,
We can
even
clean,
on that
we can
case.
clean
But-
stuff. Yeah, we can clean, man.
Yeah, but can we go
No,
like,
but
for instance,
the
arithmetic?
arithmetic
Can
we
we
are-
go even flatter than this?
Of course, I just said it.
Yeah,
how.
for example, this operation here is like totally redundant. We don't need that.
Huh?
Yeah, we can
It
remove
could
that.
be just this, for
Yeah.
example. But I just keep it. Like
Yeah,
let's just
okay.
do the thing.
Operation,
So okay, this is an arithmetic,
uh,
and what do we do with that?
Now we're gonna call evolve arithmetic.
We
Arithmetic.
need- no, wait. We need to evolve the values, right?
No, it depends on what you want to do in your interface. But in the others, you are just calling it, right? I think that's what you should do. And inside, you evaluate.
No, wait.
So I was thinking of doing this. Eval arithmetic. Oopsie. Arithmetic. Then we just pass down the environment. And then we pass the operation.
How exactly you gonna? Because I think you mean the values they can be any arity, right?
Yeah.
How you gonna do
Because we
that?
think of Lisp. Well, list.
Yeah, no, but you're gonna have to evaluate because this is a list of
Evaluate each
expressions.
one.
Oh, the
Yeah, you're
pattern
gonna
match,
map.
right?
You can you can map evaluating each one of them, and then all of them in the end should be the same type. Oh,
Yeah,
nothing about types.
not
They should
now.
be they should be like literals, which is integer in this case.
Oh,
Yeah.
fuck. I completely forgot that we are doing S expressions.
Yeah,
Oh,
this is the same thing that I did on the Lisp Ecamo Lisp thing.
Okay, go.
that
So,
might
okay.
be, I don't know, that might be a problem with the way that we did the lambda calculus core, because we don't have the partial application in Lisp like stuff.
Oh yeah, the currying. We don't have that. Plus.
Yeah.
So
Do all Lisp's languages like accept multiple arguments, like in arguments, or is it like
for
specific?
arithmetic, yes, like plus. Because this thing is not a function here. Like this is a monoid. So this, for example, is 0.
And I hate that.
I don't know what you mean, Lemos. Really.
I hate that.
This is 0. This is 1. So that's okay.
That's totally cursed, but okay.
It's not cursed, man.
Yeah, it is, man. You know it is.
Oh, okay. Let me. I don't know it is.
I really don't know also, Lemos.
So let's do lists. Fold. No, I want a map. So do we have for all? All.
For
Oh, we
each,
do.
I saw for each. I saw for each.
For each. Yeah. Okay, but in this case, it's just a map. So a map with the function, and I think functions like lambdas in Erlang is like this, and then you just do like x and like this. So that would be the value we want to take inside the thing.
I'm
Which
seeing something, Mageta. In our language, the way we are doing, it would not be possible to pass plus or return plus as a function. So in Lisp, you can
Yeah.
do that, right?
in Lisp you can if you pass it as a symbol like this.
Like when you have like the normal, how do they call it? Normal. I don't know.
Normal form.
Yeah, normal form. It reminds of something
Yeah,
else, right?
I know. Yeah.
But okay, when they have the
Who-
normal
Who
something,
joined
right?
us? Victor.
The normal way to applicate the thing, right? So they evaluate the function, and that function could result in a plus, right? And then they use that to the arguments.
Yeah.
In our language, would not be possible the way we are doing, because you are requiring the thing in arithmetic to be the operation already. So you cannot
Yes.
do that with a variable that is carrying the plus, for instance.
Mm-hmm. We
Uh,
can fix that. Like get by reference, right? But we would have to check to get the
Get
function.
by reference. I don't
No.
know. What
Not, I don't mean by reference. We should get the function as well by some environment, something like this, to
Yeah,
apply on the arity.
yeah, I think it should be a native function.
Yeah, let's just keep like this. Add for now. We can change it later. I don't think
Yeah.
it's gonna cause much
Okay.
problem now. So okay, let's change it later. That's the
Man,
That's-
this is going
that's-
so. Oh man.
okay environment, and we are gonna evolve this thing passing just as a literal. That's why I was thinking it was going to be confusing because this is an integer as I was doing. Let's just do
No, wait. Now I am the one confused because we're gonna map the list of values, right?
Yeah.
Yeah,
Yeah,
and
but
they are not values yet.
they are not values.
Oh wait.
Yeah, they are not.
Wait.
Yeah, no, I agree with you, but I think I want to
Yes,
listen to Herd Magetta.
Wait. What are you talking about, man?
They are not. They can be expressions, man.
Oh yeah, I know. That's what I'm gonna do here.
Yeah, but then why don't we rename that? That's confusing, man.
Rename what, man?
Just put expression
Like,
instead of
We have
literal.
places where we are
This is
calling
not
things
literal anymore.
values, but they are not values.
This is not a literal anymore. This is values. I mean, like the values for the application here for this function.
Yeah, but
Okay,
what we mean
okay.
is they are not values indeed. They are expressions.
Yeah.
So what's the problem?
Change for
Isn't that
expression then.
confusing?
Rename?
Because we have a we have a like specific
Man,
thing that
expressions. That's big.
Just big.
well, we have involved with environment.
Yeah, that's fair.
Okay.
That's fair. Yeah, but we have a problem. Because
something
in
is
the
wrong. Let
in
me
the
see here.
middle of the thing, uh, in the
What is
middle
wrong?
of the evaluation of the sub expressions of the add operation, we may have a problem in the middle. So we kind of have to check before returning and before executing the operation itself.
No. Who is evaluating will throw the error, man.
Yeah, but we what's
We
our
don't have
next
to
step?
check. The
Parentheses.
thing will terminate.
No. We do
Right.
have to check because this list may have an error in the middle.
That.
Wait, can you
Okay.
repeat that?
Yeah, so we have a list of expressions, okay?
Yes.
Let's suppose that we have 3 on the example on the top. Let's suppose that the middle one has a problem. The middle one got an error.
Okay, yeah, that's not a map. That should be a fold because then we can short circuit when we
That
have an
should
error.
be a fold.
Yeah,
yes.
you're right. Doesn't
Well,
make
it
sense to
will not-
evaluate the rest if you have
Well, we
failed.
could, but that's just a waste.
This is the Uga
No,
Uga
man.
way, by
Yeah,
the way.
it makes no fucking sense. Why would
This is
you
the-
continue to
So
evaluate if you
fold
had an error?
left.
Okay, so the
wait,
function
so
is
the
kind of
function accumulator and the
the function is going to be a case. That's okay.
so
The accumulator would be the buffer that we are summing up.
wait.
Right?
So let me do this, and this is the accumulator.
Yeah,
So
we
the
start with
accumulator
0.
is just a 0.
Well, don't
Okay, you want to fold with this operation already?
Yeah.
Is that it?
Yes.
Okay.
Yes.
Oh, nice. Then we only need to. Oh, that's nice.
Ah, I hate that. I hate
Why?
that so much.
Why? That's already, man.
No, the plus should be the 0, right?
Uh,
Yeah, the plus should be
Oh,
the
that's
0.
accumulator. Yeah, never mind. That's the accumulator. This should be the. Oh no. Yeah, we can't pass the function. Okay, I was thinking of another thing.
But that's the
It should
thing.
be
You
0.
also need like inside the anonymous function using the x. You also need to you need to do a case with the evol, because
Yes,
if
we need to
Yeah.
match this.
yeah
Let's break. Can I break this?
You basically evolve each one,
This
Yeah.
is
and
horrible.
if it's wrong, you return already. And
Yeah.
if it's not, then
you sum the
actually
accumulate.
yes and
Yeah,
go.
good
Oh,
thing
and
you
the
noticed.
function is wrong, by the way. The signature of the anonymous function should have 2 things. Like
Oh yeah, it should have what comes
I've-
first though.
that's a good question.
Fold. So it's deceive.
Oh, the second is accumulator. It's Haskell like.
Okay, F sharp is the opposite. Okay, so it's the element
Poggers.
plus the
Accumulator.
SSA. Okay.
Yeah.
So then we're gonna do and. I think we don't need this. We do.
Okay, we should have 2 options. Or you have a literal, or you have an error, right?
So if we have a literal, then like the literal.
This is a value, yes.
So finally I can use the value. We just do accumulator
Plus this.
plus the value.
Yeah.
That's it. And
Yeah,
then
and if you have an
this,
error, then you just pass the error on.
doesn't matter. Oh, it doesn't matter. We could
Just
do
return the error.
we could do something like Not
Oh,
reduce.
is that
What?
possible?
No,
Yeah,
folks.
not
We have
reduce.
no. We should not ignore this error, folks. We just need
Why?
to. Well, man,
Because
Because
this
this
because
error
if
error.
you
means you
evaluate the
cannot
error and
reduce.
the error is a division by 0, you don't want to.
Oh, okay, yeah, makes sense.
But there's a
Okay.
problem. Can we return in the middle of the fold?
Oh, and that's not the same. Oh man, our accumulator should be rapid because yeah,
Yeah, this should be
That's so
this.
cursed.
yeah, it is not in game.
Oh, okay.
Yeah, it
Okay,
needs to
let's do
start
like
with
this.
OK0.
So, okay.
Ah, ah.
Wait, you cannot pattern match there, can you?
I can pattern match everywhere, my friend.
Well, but then
So,
if that's an error, then what happens?
if it's an-
Oh, this is disgusting. This is
oh, right.
bad.
I get what you mean. Okay, I get what you mean. So I need to make a case. Oh, this is horrible. Okay,
No.
because
Let's assume the
I
thing.
can start like this, like okay 0.
Yeah,
That's the
but
start.
that's the thing. If you
And the
match
point is
on
that
the
you
anonymous
do,
function, I don't
then
know
it will
what
throw
will
an error,
happen.
and then the next time it's like it's not like a known, right? That I can keep doing stuff, and it's
Yeah, you
always
need
going
to
to be
pattern
known.
match this. You need to pattern match
Yeah,
target.
but that's the thing. Maybe it has a different behavior if you pattern match there on the anonymous functions or inside. Because inside, you can just ignore the
Yeah.
other case because you know it will always be okay.
Yeah.
But there, I have no idea what Erlang would do.
Oh man,
Oh,
this is the
this is
dumbest
horrible. This is
fold
gonna
ever.
be yeah. So if
Man,
it's
Oh, no.
okay,
I'm
ACC,
scared of our language being more cursed than JavaScript. I'm
no,
genuinely
it's not,
scared.
man. That's very impossible.
I don't know.
Magenta is saying that now. I know. I'm not
That's
agreeing with
bold.
him.
That's too bold.
No, man.
You can always
I
do
can already
something
listen.
worse.
I can already
Okay,
listen to Magenta.
I will quote
Silverware
the first.
is worse than JavaScript.
I will quote the first quote from Harper's book. Like the first thing he says: "If you think about types, your language design is already good."
That's bullshit.
No, that's it. It is in the right path. I can agree with that.
Well, it
Yeah.
has something of true, but you can do that and do a completely cursed language.
Oh yeah.
Haskell, for example. That's
Ah.
Oh.
okay. Case.
I have bifunctors and profunctors. Suckers.
suckers. If I don't know, if I can't understand, that's useless.
Or you are the problem.
Oh wait,
Yeah, that's a
so
really
wrong.
bad argument, Magit.
No. You guys don't know. what
Man,
I'm talking
holy, that's whole Hazera's point. He doesn't know stuff, then it's
No,
useless.
don't talk about work here.
Okay.
This is being recorded. Remember that.
So okay, ACC. Oh man, so many things are ACC now.
Yeah, does this work? Do we have shallow things?
I think yes. This is not mutating, right?
Yeah,
Can I
just
say this?
not with
Yeah, it
the
saves.
assign thing, right?
Yeah. If I try to assign, then it's a whole different game. So this is error. No man, this is really cursed. Like
You can just
the
this-
ignore this
dumbest
case,
fold
can't you?
ever made.
Hey, as we don't have
Uh,
exhaustiveness check, can't you just ignore that case? Because
Let me
it
see.
will
This
never
case is
happen.
for.
No, if you have an
No,
error,
no,
just
it
pass
will
through.
happen.
If you have an error, just pass through.
No, in
Just pass on.
practice, that doesn't happen.
No, that will happen because
What
we
do you
cannot
mean?
short
Will?
circuit the fold. We cannot short circuit the fold. Nathan.
Oh,
So this
okay,
is
yeah.
just propagating.
That's why I like for more with return.
Oh crap! Yeah, man, we're gonna die in hell, suffering.
No, wait, man. We should not overwrite this shit, man.
Hang on, this is wrong.
No, the
Oh.
indentation on shoot down is wrong also.
This.
That's the same as the beneath one, like your isn't it?
Just a second, man.
Man, this is this.
Man, I'm just telling you, Lemus. It will be cursed, man.
Oh man! Imagine when we have the man, it's gonna be ginormous. It's gonna be like multiple, a bunch of cases, like pattern matching, pattern
Oh,
matching.
no.
So this is that right?
I
No,
think
that's not.
so.
That's not right.
That's
No,
right,
that's not.
indeed.
No, that's
What
not.
do you mean?
How is that not
Because
right?
Why?
because you need to the accumulator should be an error, should be an atom error, comma.
What?
But
Because
that's
They
what
online
he is, isn't it?
for up, you are pattern matching the
Wait.
accumulator, right? And you are
Yeah.
declaring the new value of accumulator.
Yeah.
Oh, we are reusing the previous error. That's why you don't have to do the like you did with the OK one. Okay, sorry.
Okay. So
Semicolon.
here, I'm kind of
Yes,
lost.
and also semicolon in the next line.
I don't know. I
Here?
can see something cute about Erlang, but it's mostly cursed, the syntax, man.
And put a dot in the end.
This
Yeah.
doesn't have a dot. This
Oh, this
should be
does.
this. Yeah, that's why.
By the way, Lemos, despite me hating still the white sensitive shit, I'm a bit glad for Haskell not requiring the in now and the let. Even though I like the in for some specific reasons.
Syntax error before end.
Uh,
This should have that. Now
okay.
this. Just propagated error down. Okay. And now this end is because of the lambda. Oh no.
Oh, it's because we are lacking parentheses, I guess. Yeah, we are lacking parentheses
Oh.
after the
No.
end, I guess.
No.
Like,
There's
are
no
you
parentheses
sure?
here. Yes, absolutely.
Well, if you do one there, you have to do other before fun.
Yeah, other here.
Oh no, the other parenthesis is the beginning of the function. Okay, so I was wrong. Sorry.
So why do I have to add okay here? Error syntax before end.
And please, this needs to work.
Like, for me, it makes sense that the fun doesn't need the parentheses because you have fun and end, right?
Like,
So,
because the
Let's
fun,
try adding the parentheses.
yeah,
Let's
I
just
think it doesn't
try.
cost.
Like-
Oh,
the fun is like this.
oh yeah,
Oh,
yeah,
Like it
yeah.
works.
okay, so it needs to be wrong in the
So the
in the
problem is
body.
this case, nested case hell.
Is
Uh,
all. Is all.
Are you
Syntax error
sure
before
that like
end.
3 up, this is a semicolon, not a dot?
After the error, don't you need something?
After the error, don't I need something?
Yeah, no, we don't need. You don't need. You don't need Nathan.
Because here, for example, like let me see where there's a case. You see here?
22.
I just
Hey,
No, 7
don't,
up. 7 up.
don't you need a semicolon on after this end? Line 12 down?
12 down.
Wait,
say it again.
no, now it's 19 down.
19. That's why
19
I
down.
hate this.
Yeah.
But
Yeah,
okay.
because that's what it was. Like it was like this.
Syntax error before and.
Oh, wait.
Remove
This
the
is
semicolon.
for-
Remove everything from this last end.
Erlang.
Oh!
Okay, so you
Nice.
cannot add a semicolon here. Okay,
Yeah.
makes sense. Okay, it's actually
No, I'm
makes
so
sense with
excited
the
to test
syntax
this
there.
crap now. Let's test it.
What are you
Okay.
excited about, man?
Because it's
Wait a
not gonna
second.
work. Probably.
Wait, what? Wait, this ACC is warning you
Bound
about
variable.
shadowing?
Bound variable in pattern ACC.
Yeah, I think it's warning you about bad shadowing, man.
Oh yeah, I think it's also warning about shadow.
So let's see what should
This
be the
is
New ACC.
Oh no.
inner accumulator, inner ACC.
What the fuck? Accumulator value.
ACC value. I already told you guys, naming is the worst.
I think
naming
it's
is
ACC value, man.
Inner value.
Okay,
Nice.
that works.
And okay, let's try to see if this works.
Oh
This
man,
is cursed.
that's really cursed. And I don't know what we are doing. I don't know why we are doing that and just saying it. Let's do it different later, man. Because it will be hard to
Oh
like
yeah.
Well,
reduce
let's
stuff.
just pass.
No, pick the easy example with just literals because it's gonna break already, I think. And
3. That's wrong.
What
yeah,
the
definitely wrong.
fuck?
Uh, uh,
Well, we are
It just
definitely
returned.
summing it.
It just returned the last one.
can we print in the case that we found a literal in like 28 down? Can we print on
Yeah, it
that?
just returns the last one. You see?
Mm.
Oh.
Why
What?
is that?
What the?
I think. Well, let's see if it's cursed fold. So. Oh wait, we're not mapping. Are we mapping this to any value? Let me see. We're calling arithmetic, but we're not wrapping inside OK here.
Huh?
Like the result of this should be a literal, right?
Oh yeah, that's true. This should be a
So-
literal.
Yeah, we're just like returning this crap. And do
Yeah.
let, man. It doesn't have let.
Oh, Lord.
Value again. Oh, but value is. Can I do this because there's a value down there, but it's like another scope. Because
It
if it
should
doesn't
work.
enforce that, then we are gonna run out of names.
Wait,
Oh,
what
yeah.
are you guys doing exactly? You are wrapping the
it's-
value?
Yeah, we are wrapping into the
But
into
it's already
okay.
wrapped, man.
Yeah, it is. It is.
It is.
Oh no, it is not. It should be
This
a
is
literal
just an
inside.
okay. Yes, this is just an okay number.
This should be but this should be a literal.
Oh, now I got it. I got it.
Yeah, but then
We need to
that's
pattern
cursed.
match.
We need to do okay. Literal. That's it. And then
But
here
it's
we
not
do-
always an okay.
Yeah, that sucks.
That sucks.
Holy
Oh
fuck.
no! Don't tell
Uh,
me we need to pattern match again.
Yeah, you do need.
Oh,
It's
no.
the world of Federaci.
Look at this.
Holy fuck, man. I'm a bit disgusted right now.
Yeah, I am very. Okay, so literal,
Wait,
and then we just
uh,
spit okay,
Wait.
literal.
wait. I have
literal.
another idea. I guess. Yeah, I have an idea. What you guys think in 7-Up? Do you see 7-Up?
Uh,
No, we don't need to do that, man. That's what my proposal, my idea is.
Hmm.
Okay, so 7-Up. Do you see that we are doing okay, inner value plus value?
Mm-hmm.
What about putting the inner value plus value inside a literal atom?
yeah,
And then
yeah.
in the
Okay,
pattern
makes sense.
matching, we also consider that.
Yeah, I prefer to do it inside the fold.
Yeah.
Yeah.
Like it's kind of dumb, but it works.
So it starts with the okay literal 0, right?
Yeah.
Oh, look at this.
It starts with an okay literal 0. Which makes more sense. It's more consistent with the abstraction.
What the
I don't know
fuck,
what
man?
you're talking about. You're just
No, but we are
complying
using
with it.
literals for numbers, which makes
Okay,
sense.
so this we're gonna have to
But Lemus, what?
value. Wait, what is inner value?
Yeah,
Inner
put there.
value is
Literal inner value.
This.
Yes.
And then here we
And then
do-
here you go wrap, and
yeah,
then
that's
in
a
the
lot simpler.
and then in the initial state of the fold, you put the 0 inside a literal. Sorry. Go, Nathan.
Yeah.
Wait.
This should work.
Have the accumulator.
Yeah.
Man, look at those levels of indentation.
It's still 0.
Is the last
Why is
one,
it-
right?
Still, let's see the fold. Just a second. List. Fold left.
Imagine if the fold does something completely different. But okay,
Maybe we are using the
We preserve
accumulator
this.
wrong.
Yeah. it
that's
could be.
possible.
So that, and then we're gonna do. So let's just do like I don't know, man. X plus
Accumulator.
ACC
Yeah.
and
Yes.
then we just
0
press 0.
and a list
then
of I don't know 1, 2, 3,
1, 2, 3, 4, 10.
10.
Magetta, I think line 5 up's wrong, man.
Fine.
Yeah,
5
wait,
up.
5?
on the
Why?
literal. Don't we need to match with
Why?
okay?
Oh! I think that's true.
I think
That's
that's why,
true.
What do we?
maybe.
Oh yes, they're
Yeah, we are
matching. Yeah,
dumb.
man. Okay. Yeah, good notice. Good catch. Okay.
And this is gonna happen a lot, by the way, but okay.
Oh yeah, it
Oh,
will.
yeah.
Oops, not this. This.
3.
3. Okay, that's fine.
Nice.
Okay, let's try the same. Oh, no, 1 plus 2, right? So we don't have to. Okay, now we're gonna have to do that 4 more times.
-2. That's it.
The good thing is I think we will preserve those
Man,
algorithms that we are
man,
using,
the
but
boilerplate, man.
the boilerplate.
Dude, this is simple. This should be a simple fold, man.
No, but we can't because of the
Oh.
atoms, man.
Can we
What's
do
this
pattern matching?
Better matching
sorry,
what?
Vinicius?
What
Pattern
is this
matching lambdas.
Hadouken code? You just
Oh, yeah, it is Hadouken code.
But dude, can we do pattern
Look at this
matching
indentation,
lambdas?
Nathan.
Oh, yeah.
Matching
Awesome.
Erlang
Look at this indentation.
forms.
You mean like function in ML?
Yeah, like lambdas. Can you pass multiple lambdas and pattern match which one fits?
What do you mean?
What do you
Can we
mean,
pass
brother?
instead of making a case? Could we pass different fun here, like 2 different funs? I don't know, and pattern match them. That's my question. I don't know if it's possible. Probably
Yeah.
not.
Yeah, that. Hmm.
I know you can pattern match, but I don't know if you can pass multiple.
I think you will
Probably
receive a
not.
fail at runtime. I think it. Yeah, maybe it's okay, but if you got the wrong thing, he will.
Let me
fail
see
at
this
runtime.
list here. Fold, map, fold left, fold right. Oops.
Why are we doing this in Erlang again? Can someone remember that?
Yeah, I
Because
can remember.
We have the same environment for
Yeah,
different.
the idea was to use a family of languages that are within the same environment and target another family.
Okay,
I think
that's
we
why we
dropped
are
that
doing
idea.
Erlang.
Yeah.
Yes.
Oh man, I'm so sad. Holy fuck.
What do you want, man? To do this in ML? That would be boring. You do that every day. You
Ah,
wake
Yeah.
up and I want to do a compiler in ML.
Yeah, that's
And
pretty much
Mag-
it.
And
But
Mageta didn't accept C#, so
Oh
no,
no.
C
If I had
sharp
to
is
deal with C
cursed.
sharp, if I had to deal with that crap, I would be.
It's just that, Maketa, I think that the things that we want to implement in the compiler and the code generation and everything, I think they are already adrenaline and cool and difficult thing
Yeah, they are.
enough, man.
Yes, we are on pure adrenaline here.
Holy fuck, man.
No, I'm perfectly aware of that.
Holy fuck.
look at this boilerplate, man. We're gonna change like the name of the atom and the operation.
I mean, this could be a function, man. Like, let's just steal some bullshit here. So this could be what?
I think we're getting to the point that we should have multiple files, man. But okay.
Eval sum. No, eval
Yeah, I think we.
calculation.
I think we really need to implement those operations as native functions because then the native function will basically be a variable, right? The plus will be a variable that already starts in the environment.
You can't pattern match there.
I can because I can now. Oh, I can't pass because of the fold. Oh no, I could.
Wait.
Because I can make multiple declarations of this, and then I just pass this function as the fold.
No,
And
can you
then it
repeat?
decides. For example, here. Oops, here. We don't care about the stuff. They all have the same parameters, right? They all have the same. It doesn't show here. Yeah, it
Oh, no,
doesn't
no,
show.
you were pattern matching the accumulator. No, it's fine.
Yeah. So for example, here I could just get inner value So we just
Oh, no,
remove
no, no, no. But we
it.
can have an error in the accumulator also.
Yes, but we don't care about that here.
Oh, okay. Okay.
You see? Like we have another function that handles an error. So
Okay.
eval calculation. That's much better. Eval calculations. And then we don't care about the thing.
Yeah.
We just care if it's an error. Eval
Yes.
message. I don't know.
Yes.
Oh, that's nice.
And then we just spit the error. Error with the message again.
Yeah. Make this in one line, man. It's better.
And then next one.
Next one.
Let me see.
Yeah, I don't have a next one, Magit.
Yeah, they don't have. Yes. I think we can do another one.
Why?
Can we do partial application in Erlang, like natively? I don't think so, right?
Oh, that would be great.
Yeah, but
I don't think
we
though,
can.
because you have the. How can I say?
Oh wait, the environment here is unbound.
Oh, yeah.
Oh, kill me.
You're gonna have to pass that.
Kill me.
You know what's even better? You're gonna have to put a slot for the environment in another one.
Let's do this. We can change these names.
Hey, I would like to ask you guys, Mageta, Lemos, Vinicius, what you guys think about breaking up bigger functions into smaller ones just for the sake of it? Like, even though the function is concise in the term of domain of thing that we are dealing with, you want to break just because it's bigger, right? Because it is, like, it will be smaller, but you are causing more indirection, right?
But
Yes,
you're
I
also
don't like this. Yeah.
no, but you're also removing boilerplate in this case because we
No,
would
no,
have
no.
to copy paste that 4
I'm
times.
not talking about any particular case here.
Oh, okay.
I'm just talking about you have a function that is big, but has a concise domain. It's like doing one thing, you know?
Oh,
But
you're talking
someone
about
wants to
the
break
grug
it.
crap.
Hmm?
You're
No,
talking
I'm
about
not
that
talking
part of
about
the grug
anything.
text.
No, I'm not. I don't know what you're talking about.
Because the grug test has a part of the related to separation of concerns versus what is the name of that? It's exactly what you're talking about.
Oh,
It
the
is more
thing of
concise.
locality, right?
Yeah, locality.
Yeah, I'm not sure if it's exactly the same, but
Yeah, it's related at least.
How should I put it here? Because I need to pass this thing, but this cannot be. This needs to be the same. Oh man, this needs to be inside this function.
Oh yeah.
Oh
course.
man, that's cursed.
No, it's not cursed. It's not. Wait.
It
Yeah,
is.
it's not cursed. You can do the following. Instead of having 4 eval arithmetics, you can pattern match the operation, right?
Yeah, which I'm already doing.
Yeah, and then no, you're not pattern matching the operation. We are overloading the function.
That's
Because
pattern matching.
No, it is, but I mean, like instead of doing add, you do operation in here, and then you pattern match the operation inside the eval arithmetic, and then you call the wrappers.
Let's just do the basic first. Wait a second. Otherwise, I'm gonna get lost, man.
Okay.
So this, and then we do eval calculation. This, that. Actually, no. Never mind me. So we have this, right?
Why are you undoing them?
What am I doing? Wait.
That is the following.
So,
The wrapper
wait.
is equal to lists.
Yeah, but I need to get out of this because I cannot put it outside because I don't have environment.
Just put the environment as a parameter.
But then the parameter here would be different. Because I need to comply with the value VACC. I need to comply with this.
I agree.
So how do I achieve this? How do I comply with V value plus accumulator while passing this with pattern matching? I can't. I need to do pattern matching inside the thing.
Yeah.
Oh, this is horrible.
Anyway, answering you, Nata. Depends. To me, depends. Even if the domain is concise. Usually, actually, it's kind of the opposite. Usually, the domain is not that concise. It's really diverse.
yeah.
and then I don't feel bad about breaking into smaller parts. But if it is concise and like reasonably concise, and then that's bad because reasonable is kind of subjective.
Wait, can you repeat that part?
Yeah, because if the thing is reasonably concise,
Okay, I can do this.
I will not break even if it's kind of big.
Okay.
But that's a problem because I said reasonably concise, and that's bad
It's your
because
opinion, right?
yeah.
I think I can do this. Okay, this is fine.
But
I
Mageta,
mean,
we have a
not
problem.
fine. What's
You
the
know why?
problem?
Because the function that you put into eval calculation is the one that we use to do the.
Yeah. What's
Yeah.
the problem?
So my problem is, what is the wrapper doing if it's
The
not
wrapper
inside
is
of code?
just. Wait a second. This. So, what? I have environment. I have X. Why is it?
No, it's indentation, man.
Yeah, no, but it's showing this. Like, what is this? List. Oh, okay. I need to save the thing. Oh, I think it needs to be this. Is that it? Oh, but I can't shed. Oh man, but I can't make another one.
Yeah, that's what I'm not getting. Why are you
It's horrible.
using the
No,
wrapper?
because I thought, can I make a new function here that has the same label as this thing? So I just pass that function instead. But I am inside the environment, so I can just pass the environment here. But I cannot do that because this language doesn't let me do this. Like it doesn't let me declare another function here. I can't do
Oh,
that.
that was your intention? Yeah,
Yes.
that was pretty unlikely from the beginning.
Oh man, this is okay. I give up. I will just do the case outside. Bye bye. I give up. Give up my hopes at this point.
Come on, man. We are on the first session.
Oh yeah, we have many more to come. How exciting. Okay, so this we can do. Yeah. And then oopsie. This? What? Okay. Oh, what the heck, Emacs? Okay. Oh man. Do we have a formatter? Probably it's not gonna do a good job, but we can try.
Yeah.
Okay, eval arithmetic, and what was I doing here? Okay, I was doing the subtraction. But do you agree that this function is now generic? Oh no, it's not. This one could
You
be.
have the plus there.
Yeah, the plus here. Man, I don't want to keep copying these all the time.
Can we think about if they are really interchangeable? All the four operations, the same structure, only change this symbol here.
Let's
no,
just
no, it's not.
copy
No, it's
this.
not. No, it's not.
Like
Because
the
the
division, for
multiplication,
instance.
the multiplication needs to change the initial accumulator also.
No. Okay,
Yeah.
but assuming also this on the foot.
Oh wait, this is
Like
Okay.
we
Yeah, the
know,
division is really weird. The
we
division
know-
is pretty weird.
we know that the sum and multiplication are exactly the same. Like you just change the
Aside
initial
from the
value
accumulator, yeah.
and
Yeah.
the operation. But
Yes.
what about minus and division? Are
Yeah,
they
the
behaviors
minus-
the same when you have non-argument, when you have one argument?
The idea that maybe I'm wrong, but I think in Lisp, if you do the like minus in a list of things, it's gonna be like subtracting from like left to the right or right to the left, whatever. The division, I have no idea.
yeah, I don't know as well.
I think the initial value
Oh.
of the division is like 1, and you do 1 divided by the one thing.
Yeah, so they would have to be on the opposite side, right? It would have to be 1, it would have to be the value divided by this, and then we have to swap the order for consistency.
Yeah, like in the case of sum and division doesn't matter, but in case of
Yeah, in this case it doesn't matter. Yeah.
but the
this
case
case doesn't
in
matter.
subtraction, is it the same of the division? If not, we are screwed. Oh, we are not because it's a function.
Interaction
No, yeah, we don't
distributes.
need to care about that. It's a function that you will pass those to. So the function will choose.
What do
Okay, you want me to pass this as a high order function.
Yes, because if you pass as an operator like this, then we have too
Okay.
much stuff to care about.
Yes, I agree.
Wait, can you explain the problem? What's the problem of doing
we
sub?
have to worry about the order we are evaluating stuff.
No,
like
no,
in
we
some
don't.
Addition.
The developer that is calling the function needs to care about.
No.
No, man,
Yeah.
no. You didn't get the problem.
Isn't
like,
the
for
commutative
example,
thing?
here,
Like, what is the name?
what
of
is the neutral element of division? The neutral element for division is 1, but when it's on the denominator.
Okay.
If we were doing
agree with that.
1 over value, we're just like halving everything. Like, not halving, but like.
Yeah, we are
1
doing
over
mass. I
X.
agree.
Yeah. So what we should do here is allow, instead of like just passing a shitty atom, we allow the dude to pass a high order function.
What's a high order function would?
I don't know, man. Like,
Can you
it
give
could
me an
be
example?
like add operations, something like this, and then we pass a high order
B,
function.
right?
A, B. I think it's like this.
Oh, the developer calling the operation would determine the order.
Yeah, exactly.
Ah.
No, I mean we determine the order on plus blah blah blah,
Yeah,
but
yeah,
we
yeah,
just
yeah.
and we match here. Like we don't need to keep repeating the
Magetta,
code.
Can you go to the
I-
part
oh,
of
I get
the default behavior of division again?
The fold,
Default
The full.
the default behavior of the function again.
division.
Okay.
Like you said that starts with
Let me
one,
just see one
right?
thing. Just run. Why is it? Oh, here. Okay, these things on Emacs are kind of annoying sometimes. Okay, so the default case on division is 1
And if I have
when it's
only
on the
one,
denominator.
I don't know. I don't understand when you say like that.
Denominator,
See-
the division part. So it's
Yeah.
1 over.
Yeah,
so
but I
it's like,
think
I don't know,
I'm
the value.
mistaken. What is the value? What is the inner value? So when you pass 2 to the division, what is the expression
Oh,
that
but
happens?
wait.
Because I think it
What-
is 1 over 2.
When you do this in Lisp, what happens?
Yeah, that's the
no,
question.
no,
actually.
put only the 2. Yeah, that also makes sense, but put the case in which you have only one number, like 2, for instance. Two.
What? Only one number?
Yeah, and the number is 2. Like put the 2 instead of 1, right?
I don't know why we're thinking.
Yeah, just execute it.
I don't know why we are thinking.
So it does not have a neutral value. That's strange.
Which makes sense. Which makes a lot of sense. Thanks.
One.
Why you're
two.
why you did crap with the
Oh,
plus and
no.
the minus?
Look at why.
plus and the
It's a
multiplication.
fraction.
Okay, but
Look
now
there.
put the 3 after that.
Yeah, put another number there.
1, 2, 3.
Okay, it does make sense that, but now put only one number, only the 2, for instance. Is it 2 or is it half?
One
See,
over
it's
two.
half.
So it's, yeah.
Yeah, so it's the opposite of what we're
But
thinking.
it's still, we don't have a default case apparently, right?
So, folks, I will do the following. Nathan, can you enter here? I will go have dinner. I'll be back in 15
I
minutes.
don't
so
know how can I
No,
enter.
we are done. 1 hour and 52 minutes. I think we are okay for today.
No, we can continue if you guys want.
No, I actually am pretty exhausted today, so
Okay.
we can continue.
Yeah, I
You
gotta
guys
go
can
too.
continue later. So yeah, so that's
I will
pretty much
end the
it. You can
stream
finish, Nathan.
here.
Ugh.